How to add and subtract rational expressions. Example B. Perform the given operations and simplify. We have x minus 1 over x squared minus 25 plus x over 5x minus 25 minus x minus 2 over 10x plus 50. We first want to make sure that we have a common denominator. If we don't, we will have to find the LCD. Since all of our denominators are different, we would have to find the LCD now. We can do this by factoring each of the denominators. If we take x squared minus 25 and factor that, we end up with x plus 5 times x minus 5. 5x minus 25 factors to 5 times x minus 5. 10x plus 50 will factor to 2 times 5, right? That's the 10. We can factor out a 10 from the 10x plus 50 times x plus 5. Now remember, the LCD is the product of each unique factor. So if we look at all the factors that we have here, there is a 2, there is a 5, there is an x plus 5, and there is an x minus 5. To the power of the greatest amount of times it appears in one of the denominators. So here, 2, there is only one 2 in this denominator, so it would be 2 to the first power. 5, there is only one 5 in this denominator and one 5 in this denominator. So at most, the 5 appears once in any given denominator. X plus 5 appears in that third denominator and in the first, but once again, at most one time. So that would be to the first power. And similarly, x minus 5 appears in the first denominator and in the second denominator, but once again, at most one time. So if I want to simplify what the LCD looks like a bit, well, this would be 10 times x plus 5 times x minus 5. Now we're going to use this expression to help us rewrite what we were given. Starting with x minus 1 over x squared minus 25. So we think about it, we want to multiply by something so that our result ends up with a denominator that represents the LCD. Well, x squared minus 25 is x plus 5 and x minus 5. And if we take a look at the LCD, the only factors that are missing are the 2 and the 5, which make the 10. So if we multiply the first rational expression by 10 over 10, this will help us get the LCD. I'm going to go ahead and simplify this up. So this would be x minus 1 times 10. That could be distributed, giving us 10x minus 10. Remember, this is all over the LCD now, which we could go ahead and write as 10 times x plus 5 times x minus 5. Okay, moving on. We've got plus next. Let's go ahead and do that. Plus x over 5x minus 25. Okay, in 5x minus 25, that is a 5 and a x minus 5. So if we take a look at our LCD, what is missing here would be the 2 to get us the 10 and the x plus 5. So we're going to multiply by 2 times x plus 5. Remember, we're multiplying this to the numerator and the denominator, multiplying by a form of 1, so we're not really changing the value of the expressions here. Okay, so simplifying this up a bit, we end up with 2x squared plus 10x in the numerator over, once again, the LCD, 10 times x plus 5 times x minus 5, minus x minus 2 over 10x plus 50. And just like how we did in the last two expressions, 10x plus 50 is 10 times x plus 5. So what would be missing here is just the x minus 5. We've already got the 10, we already got the x plus 5. So multiplying by x minus 5 to the numerator and the denominator. Okay, so we have x minus 2 times x minus 5. Let's go ahead and write that out. That would give us x squared minus 7x plus 10, all over that LCD of 10 times x plus 5 times x minus 5. Now that we have the common denominator for all of the expressions, we can go ahead and add and subtract the numerators. And don't forget to distribute minus signs accordingly. So in the numerator, we end up with 10x minus 10 plus 2x squared plus 10x. Now, if we look at our next expression, we have a minus sign here. So that's going to be distributed to all of the terms in the numerator. Remember, we are essentially subtracting the polynomial x squared minus 7x plus 10. And when we subtract polynomials, we distribute that minus sign, then combine any like terms along the way. So that becomes minus x squared plus 7x minus 10. And once again, that was all over the LCD of 10 times x plus 5 times x minus 5. Alrighty, all that is left to do here is combine any like terms in the numerator and simplify if possible. So let's see, we've got a 2x squared minus an x squared, so that'll leave us with just an x squared. And it seems that we have 10x here plus another 10x here, so that's 20x, plus a 7x, that is 27x. And any constants? Yes, we do. We have that minus 10 and another minus 10. That becomes minus 20 over the LCD of 10 times x plus 5 times x minus 5. From here, we would want to see if any of this can be simplified by factoring the numerator and the denominator. But it looks like x squared plus 27x minus 20 cannot be factored, and therefore this expression cannot be simplified any further. So we are done.